Density is defined as mass per unit volume. Mass per unit volume. And what we mean by that is how much mass there is in a given volume or a given amount of space. How much material is crammed into a certain amount of space. So the equation is this. The equation for density is density equals mass divided by volume. So mass per volume, the definition leads directly to this equation. And instead of writing density as mass over volume, we usually write that using variables. And the letter that's commonly used for density is the Greek letter rho, and it looks like this. It looks almost like our little p. It's about the same size and shape as a lowercase p, but it's a Greek letter, and it's not quite a p. It doesn't have the little tail part sticking up there. It's one smooth, continuous curve, the Greek letter is. And it's called rho. And when you read it, you just say density. That's actually the lowercase r in the Greek language. It makes the r sound. So density is mass over volume. We typically use little m for mass and capital V for volume. So that's the equation for density, mass over volume. So from that equation, you can see what units density might be measured in. Mass could be, for example, in grams, and volume might be in cubic centimeters. So density could be measured in grams per cubic centimeter. Or in the English system, you might have pounds per cubic foot. Both of those would be units for density. Any unit of mass divided by a unit of volume would be a unit for density. But those are two units that are fairly common. Here's a table showing the densities of several different materials, and all of these densities are in grams per cubic centimeter. And just look at the list on the left. The left column is solids. And balsa wood, you've probably held some balsa wood before. It's very lightweight, 0.12 grams per cubic centimeter, even lighter than styrofoam and cork. Other types of wood are heavier. Pine, for example, typical pine wood has a density of about 0.5. Other types of wood, like oak, that are heavier, would have a higher density. Take a look at ice. Density of 0.92 grams per cubic centimeter. Compare this to the density of water. Water has a density of 1, exactly, 1 gram per cubic centimeter. Ice is less dense than water. That's why ice floats. If you have a soft drink, the ice floats to the top instead of sinking to the bottom. Or icebergs float on the top of the ocean instead of sinking to the bottom, and that's because ice is less dense than water. Metals tend to be heavier than wood, for example. Aluminum, one of the lightest metals, has a density of 2.7, and other metals you see have a density that's much larger. Iron and copper are much heavier than aluminum. Lead is very heavy. If you've ever held a piece of lead, like a fishing weight or a shot put, you recognize that it's very heavy for its size. There's a lot of material packed into a given volume, a lot of grams in a given cubic centimeter. Gold is even heavier. If you've ever held a piece of gold, it's very, very dense, much more dense even than lead. Most people, when they hold a gold coin for the first time, their comment is, "Man, that's heavy." And you just recognize that you're not used to feeling that much stuff packed into that small a space. In the middle column here are some liquids. Notice that alcohol and oil are less dense than water, so they will float on the top of water. If you ever spilled some oil, say spill some cooking oil in the sink or something like that, it floats on the top of the water. Or if there's an oil spill from a tanker, a ship, and the oil spills out, it floats on the surface of the water. And that actually helps them. They're able to clean it up a little bit easier. It's still a big mess, but they're able to clean it up more easily because it floats on the surface instead of sinking to the bottom or just dispersing immediately through the water. The fact that it floats allows them to access it easier. Salt water is more dense than regular water. As a result of that, it's easier for things to float in salt water, and we'll talk more about that later on. Over here in the right-hand column are gases, hydrogen, helium, and regular air. And in grams per cubic centimeter, you can see that these numbers are very small, much, much much, much smaller than the liquids and solids that we looked at. Air has a density of 0.00129 grams per cubic centimeter. That's not very much. It's lightweight compared to solids. However, hydrogen and helium are even lighter than air, and that's why a balloon filled with helium will float, or a blimp filled with helium or filled with hydrogen will float, because hydrogen and helium are less dense than the surrounding air. And let's take note specifically of the density of water. This is something that you should know. It's 1 gram per cubic centimeter. That's just a fact you should memorize. 1 gram per cubic centimeter. Sometimes that's written as 1 gram per cc. And a cc is just an abbreviation for cubic centimeter. I prefer to write it this way because the algebra works a little bit better. This really is a centimeter cubed. But cc means the same thing. And you see this terminology used a lot in medical applications. For example, a medicine dosage might be a certain number of cc's. A cc is simply a cubic centimeter. And that's the same thing as a milliliter. So the density of water is 1 gram per milliliter. And ml means milliliter. That means 1,000th of a liter. So all of those are the same thing. A cubic centimeter is the same thing as a cc and the same thing as a milliliter. So the density of water is 1 gram per cubic centimeter, or 1 gram per cc, or 1 gram per milliliter. It's also 1,000 kilograms per cubic meter. So that's equivalent to 1 gram per cubic centimeter. So if you picture a cube that's 1 meter on a side, so this would be probably a little bit bigger than a washing machine. 1 meter deep, 1 meter tall, and 1 meter wide. Picture a cube that size filled with water. The mass is 1,000 kilograms. There's 1,000 kilograms of water per cubic meter. And that's a lot. That's a big number. 1,000 kilograms is 2,200 pounds. That's a little over 1 ton. In fact, 1,000 kilograms is referred to as 1 metric ton. So a washing machine filled with water weighs a lot, especially if it's a large washing machine, because the density of water is 1,000 kilograms per cubic meter. In the English system, the density of water would be about 8.3 pounds per gallon. 8.3 pounds per gallon, or about 62 pounds per cubic foot. You don't need to memorize those numbers, but you should memorize this. The density of water is 1 gram per cubic centimeter. That's easy to remember, and it's just a good fact to know.